This video is about momentum. So momentum is the strength of a moving body, and it's all to do with how much mass that object has and its velocity that it's going at. So momentum is mass times velocity. The units for momentum are kilogram meters per second. Because if you were doing algebra and this was just m and v, to simplify you'd just put mv. So you've got kilograms times meters per second, so it's just kilogram meters per second. Now, the rule about momentum that you're never told, but they will expect you to remember, is that the momentum before a crash or an explosion is equal to the total momentum after the crash or explosion. So basically, they're equal to zero because they're positive in one direction and negative in the other direction. So you need to remember this. It's called conservation of momentum. So I've got an example here. I've got this car here that's going to crash into this stationary van. I know it's stationary because it's moving at 0 meters per second. And I'm just going to calculate its momentum. So the momentum, the total momentum before is the car. So it would be 1,500 times 15 equals 22,500 kilogram meters per second. The van, its momentum is its mass. So 2,000 times 0, because it's not doing anything. And you all know that when you times anything by 0, you end up with 0. So the momentum for this is 0. So the total momentum for this whole situation beforehand is 22,500 add 0. So just 22,500 kilogram meters per second. Now in the exam, they might give you something that looks like this, so a situation here, and then give you an after situation. So we've had a collision here. Apologies for the poor drawing. And they'll just ask you, what is the velocity? And you're like, hang on a minute, how do I work that out? And they're assuming that you've realised that they've already given you the mass, so they're not going to tell you that again. So you remember this rule here. So working out the momentum for this situation, so it would be P equals m times v. So the mass is the total mass for this situation, and they've joined into a nice big mess here, so it's just one great big mass at the moment. So it's 1,500 plus 2,000 times v, which we don't know. So P is equal to 3,500 times v. Now we all know to find out one of the things you need to know everything else, but we do know P, we know momentum. We've just worked it out here because the total before has to equal the total afterwards. So the 22,500 is equal to 3,500 times v. So to get v in its own, you bring the 3,500 down, divide it, and that gives you 6.428,571. Now, a lot of the times they'll ask you to do it to an appropriate number of significant figures or 2 decimal places. Now, the appropriate number of significant figures is usually around 3, so I would round this to 6.43 meters per second. Okay, now another thing about momentum is that they can relate it to force. Now, you're not given this formula on the formula sheet, however, sometimes they're nice and they will give it to you within the exam question if they're feeling nice that day. Force that you feel is equal to the change in momentum, so what it started at to what it ends at, divided by the time taken for that change to actually occur. Okay, so in an exam question, you might have just worked out the momentum and then they say it takes this many seconds, like usually 0.0 something. What is the force felt? So you just take the number you worked out before and divide it by whatever time they've given to you. And if they want a unit, remember it's in newtons. Now, increasing the time taken for the change actually will decrease the force felt. So for example, if the change in momentum was 10 and it took 1 second for that change, then it'd be 10 divided by 1, so it'd be 10 newtons of force would be felt. However, if that time taken for change was 2 seconds, that then reduces it to 5 newtons, so it does make a difference. Sometimes in the exam they'll ask you, why would a bowler recoil or pull back their hands, not a bowler, a catcher, pull back their hands before catching the ball? Well, that will increase the time taken for the change in momentum. Also, crumple zones in cars, why do we have them? Increases the time. And they can also relate it to things you would never even think about, like soft children's play playground surface. I think I've even seen it related to a person's trainer as well. So they can be a little bit sneaky when it comes to momentum, but don't get confused by the P. It's just a symbol. They tell you what it means, and just practice it. Okay, there usually will be a question of, you need to work out a before situation and an after situation.